Hello, everyone, and thank you for joining today's session. My name is Irina, and I'm the event planner for the Redmond Reactor space. Before we get started, I have a few things to go over. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience as well as our presenter. We encourage engagement in the chat, but please be mindful of your commentary, remain professional and on topic. Useful links will also be shared in the chat. This session is recorded and will be available on demand in 24 to 48 hours on the Microsoft Reactor YouTube channel. Which brings us to today's session. The session will run approximately 1 hour with questions throughout, and I'll now turn it over to our speaker for introductions.
Hello, everybody. I am Sam Wronski. I am a regional cloud advocate here at Microsoft. My job is to help empower all of you to build awesome things with Microsoft technology. What we're doing today is part of the Reactor Code Lab. We're exploring dependency injection, specifically dependency injection in .NET. But a lot of these principles apply across software development. Dependency injection is not unique to .NET in any way. It's a software design principle. Sort of based around inversion of control. We'll get into that. But the reason we're diving into this is because I have mostly used dependency injection either something that's already built in. For example, .NET automatically injects a logger into your controllers, but I don't know how to do that myself. At least not to the point where I feel comfortable actually like deploying code with it. So we're gonna figure that out. And then we're also going to kind of talk a little bit about why dependency injection is actually useful and not just something to make your code more complicated. Because a lot of the times that's sort of what it appears like when you're first writing something is why are we suddenly creating a new interface when we don't need to, and creating a weird way to just automatically assign this variable? Why can't we just say this class is assigned to this one? And there's a lot of reasons for that. Most of it relates down to testing and how to make software just a little bit more reliable and modular, so you can actually take something and plug it into something else, sort of like changing the wheels on your car or some other part. But that's what we're going to do. So I have pulled up this doc, and we're just going to kind of work through this and hopefully poke at a few different things. I also have a web API here, and we're going to kind of rely on that as sort of our test platform to figure out all this stuff. And I just kind of want to get to the point where we can write some sort of model, get that created, and then test it and actually see what's happening. So let's get started. The first thing that this gets started with is actually just creating a message writer. Typically what you're going to use dependency injection for is to abstract out specific dependencies in your services. So in this case, we're abstracting out a message writer. I'm actually going to use some other counter service, I think is what we're going to call this. And so why you'd want to do this is, let's say you're creating a series of microservices. You have a bunch of services that call other things, maybe go out to a database and retrieve some data and do some calculations, but it's not all self-contained. It doesn't all exist in the same app. How do you write a test over that without spinning up the entire infrastructure? How do you actually get that set up? And so typically the way you do that is would set up all of that. You'd have some sort of test database set out somewhere, and you'd have a bunch of services that you had just kind of running, and your test would go out and hit those services and return back. But that introduces a lot of complications into what you're actually trying to do. Your test can fail if somebody goes in and changes the data or the database is down. And maybe that isn't what the test is intended to do. And so it just introduces all this extra noise onto something that is already pretty complicated. By making something, by allowing something to be dependency injected, by inverting the control structure of how that is actually assigned to the object, you can actually make it so that your test can just inject some sort of mock service in that automatically does the same thing every single time, regardless of how else it's supposed to work. So that's what we're going to do, is we're going to create some sort of service. So let's create that. Let's go and create a counter service. And this is just going to be something that counts for us. So let's actually, I can use this, I think. Or not. All right. We're just going to do counter service. Yeah. So, all right. So we have our counter service. This is going to be the service that we're going to kind of be injecting into things. And so there's going to be a lot of different things we're going to do. Typically, this would be something that is like reaching out to an external service or something else. In this case, I'm not going to add the external service. That's extra complexity into this example that we don't really need for this. But the advantage of doing that is, again, you can pull out those external services and make them something that is modular, that can just be thrown into something or swapped out really quickly. It's why loggers are injected, so that you can actually change the logging framework that you're using pretty quickly. So we have our counter service here. Let's add a few other things. What's going on here? Apologies for the train. So let's go and do two functions, I think. So this counter service is going to have a private int. We're just going to call it the count. And let's have a public add count. Yes, and that's just going to add an integer to that. So let's just say amount. And so what we're doing here is just incrementing our count by some amount, and we have some sort of getter assigned to that. How do I want to do this? I think we can do a public int with a private setter. I think that might be the way to do this. And that way your count is always assigned to 0. and then we'll increment with time. So this gives us a quick way to kind of do that. And then we can just add to this and then get the count back just by reading the property. The advantage here is that now we have a function, we have a property, we can work with this. We're probably going to want to abstract this out into some sort of interface later, so we can actually more easily test this, but we will get to that later. So here is our counter service. Now, let's go and look at this. So what's happening here is they're actually directly injecting, or not even injecting, they're just assigning their message writer directly inside of the service. So if we do that in our, do we want to do this inside of the weather forecast? Let's make our own controller here. We'll just call this the count controller. So we're going to rename this and remove most of the stuff here. So we're going to get rid of this, and we'll keep the getter for now, but it's just going to return this. So let's do a private counter service. There we go. So that's going to be just a reference to our service. So we're going to do exactly what was happening previously and just assign to it. So now our counter service is directly assigned there. And then we're just going to return the services count. And so now we have a service that just returns some sort of value. And this should now be an int as the result. We'll say get count, cool. And this is the count controller. And we'll swap out the type of the logger. All right. Bunch of stuff changed, but now we've kind of simplified our controller down. And so what we're doing is we have this getter here, just going out to that service and getting the current count. And so we're going to use that as a way to kind of reference going out to a service and actually invoking something else. So we're here, basically. We've copied most of this. I'm kind of going off on my own just to kind of learn a little bit. But that's sort of what we've done. So let's actually run this. So let's do .NET run. And hopefully I haven't screwed anything up. And this actually compiles and runs. And then we'll get our service here. Let's go out and actually hit that. So if we go here to, I believe it's the count service. And there we go, we get 0. So this service just constantly returns some integer. Let's make that a little bigger. And so we're just going to get some integer back of whatever the current count is. So what I also want to do is write a setter. So we're going to have something that can accept a post. Do I want to do this? I I don't actually know if I want to do this, but we're going to do it anyway. Actually, a better idea might be to throw this in here, and let's do int amount. I'm going off of my plans, but that's okay. We're just going to assign this, and then what I'm going to do is actually do service.add count of our amount before we do this. So what this is doing is actually incrementing this count over and over. Hello, welcome to the stream. And so every time we invoke this now, we're actually, if we have a count in amount inside of what we're actually trying to do, we're going to invoke that and run it. So in this case, I can now go here and refresh, and we should, well, I didn't restart that. So that's not going to change anything. So let's try this again. Let's rerun this. And so when we rerun this now, I can add an amount as a parameter inside of my URL, and that should increment the service's amount. The service is going to be scoped. So I think if I do amount equals 1, we'll get 1. And we'll continue to get 1 because the service is actually scoped. So every single time we invoke this controller, we're creating a new one, which means we're actually recreating this entire thing. So that service is getting recreated every single time we're trying to invoke it. So that is how this all works. The downside is, what if I want to test that when I invoke this get method with an amount, it increments the service? How do I do that? There isn't really a way to do that. We can kind of cheat it because our service returns the count. But if this return statement wasn't here, if this was returning something else like 0, there's no way for us to know that our service incremented without actually getting a reference to that and doing something about it. And if we're actually trying to refer to like an external service that is something we depend on, maybe a database or some other like a website or API, this isn't an easy way for us to actually test this. And there's no way for us to really pull that out either, because inside of this, we're assigning it into a private variable. So nothing else can get in here without like reflection to go in and actually change what this is pointing to. So there's no easy way to actually get rid of this. We've just basically hard-coded this and said, anytime you interact with a counter service, or anytime you interact with this service, you mean to interact with this counter service, and there's nothing else that you can choose. That's it. That isn't exactly what we want. Typically, we want some way to actually abstract these things. We want to be able to, at least at the very minimum, test this. But this is sort of the default pattern a lot of the times you'll start with. And then we can kind of get into inversion of control, which means taking this control structure and having this controller assign what it needs, and instead have the controller ask, which counter service should I use? And so by inverting that control, we can actually inject something for or for actually performing the action. We can say, in this context, maybe you want to perform something differently on Linux versus Windows. You can do that, and you can just automatically have the platform detect that and inject it into your controller. So that's that. That's what we're going to get into. I might have gotten ahead of myself because we're still learning. So we have our dependency injection addresses some of these problems. I've talked a little bit about that. So next step, let's add a interface. The reason we use an interface is it gives us a template. It gives us a contract for how to actually abstract this thing. So we have this concrete class definition. But what this really is a series of different interfaces that you can actually interact with, a series of different contracts. In this case, the contract is that it has an add count function, and we can get the count out of it. That's it. So let's go and actually add that as something we can reference. So we can go and do I counter, I guess. That'll work. So let's define our interface as an I counter is going to be something with a int count that has a get function. So we're not going to define a setter. These don't need setters. And the other thing it needs is the ability to actually add a count with an int amount, and that's it. And so this is our interface now. And so what we can do is now take this and say our counter service implements this. And the other thing we can do is if we ever need to write tests over this or something else, we don't need to extend this counter service. We don't need to include all of the behavior of this counter service and then extend the parts that we need. That can cause a little bit of weird flakiness because then you're inheriting all of the behaviors of this service, and that might include more than what we've defined here. And if that's the case, it might behave differently than you expect if you're starting to inject that, and it could change over time. The cool thing with using an interface is there isn't any implementation details behind it. It means you can actually rely on that being empty. So you're going to get a syntax error if you don't follow this behavior. So if we delete this, now we have a compiler. We have a syntax error because we haven't implemented the contract. And so this gives us a concrete way to actually say, here's what's expected, but we're going to actually leave the implementation up to individual users. So ideally, you document what this means, but in testing, what this means is that you can actually swap these out. You can change these behaviors to whatever you want. And that's pretty much what we're going to do. Is we're going to have something where we can take this count and the ability to add a count. Typically, again, this is kind of sitting in place of what you might have for like a testing thing. So this is probably something more like what your test would look like than what your actual implementation would look like. But that's just how we're working. So that gives us that interface. What we can do now is actually inject that interface and say our controller, our platform, is actually going to inject this type of service into something else. So that's what this line is doing. There's a bunch of different options here. So I'm going to copy this for now, and then we will kind of change it a little bit as we go. Let's throw this, I think, oh, that's not going to work. Let's copy this again. There we go. And introduce this. So we're going to have a builder. It's going to configure our services. I believe I already have services, so that's already done. We're already in that function because that template is not for single line or single file things. So we can actually get rid of most of this, I think, and just go to services. And then none of this stuff is defined. That's fine. So in this case, we're adding a scoped thing for an I counter. So this is the type that it's matching. So yeah, this is the type it's matching, and this is the type that we actually want that to implement, which is going to be the counter service. So we're providing an I counter of type counter service. So this gives us a way to actually inject that. And then I'm not sure what this is. So let's go and figure out what this line is doing. And then I can figure that out. I don't know if I've used this before, if I've seen this before. Maybe I have. Adds a scope service of the type specified. That's not right. Add an I-hosted service registration for the given type. Oh, that's because, so this example is using a message. It's using a background task, a background service inside of the example. So we actually need to add this hosted service as well. And that means that it will actually be part of this whole life cycle and we'll actually receive the dependency injection. I'm using a controller, which should already be there. So I don't think we need that. I think we can just skip that line. If you are using a background service, though, you would need to add that there. But we should just be able to add a scoped I counter that's of type counter service. Now, I believe we can just go and find a way to reference this. So scrolling back down here, we can look here is the background service. What this is doing is taking something from a constructor. So taking an interface argument in the constructor and injecting it into this. So just automatically getting it received from something. These background services in the controller isn't something that you handle the construction of. That's something that .NET is going to do for you. And so we can rely on that to kind of provide us the context that we need. So we need to include this. So where we have the iLogger, let's also add an iCounter. I don't believe the order matters, but we can find out pretty quickly. So let's add a counter service. And just to follow the naming convention, let's just do counter service, just so that we are somewhat in line with what is already there. That probably doesn't matter too much, but we're just going to do that because it's nice. So we have an iCounter service. We also have not swapped out this for the interface. So I can do that, and then we can actually remove that initialization. And now this counter service should be injected automatically for us. We should automatically see this come in from what we're trying to do. So let's find out if that works. If it doesn't work, we're going to get a null pointer error. So we're going to know pretty quick because we're going to try to invoke it. And I renamed it, so that's not going to work. Let's do that. Probably much happier now. All right, and then let's run this. And hopefully everything is good. Perfect. And let's go, and that's not right. Run this. Cool. All right, so we're not getting any errors. The downside of this kind of approach is that some of the errors that you're going to see are going to be runtime errors because it's trying to do something at runtime to fulfill that contract that you specified. We've said this controller requires that there is some sort of service or some sort of interface that matches this specific contract existing in our platform. If we take that out, that should break. So let's do that. Let's just go and remove what we just did. So we're just going to take that back out and rerun this. And I think this should compile just fine. And it does. So we don't get any build errors because all of this resolution of stuff happens at runtime. And so we're not running our code, so we're not going to see those runtime errors until I try to do this. And then we get a really big thing that says unable to resolve service of type iCounter while attempting to activate our controller. And so this is the error we're going to see. The downside of this is our app. This is running at runtime. So if your app builds, it's fine. But if you run it, this can happen. So this is why testing is somewhat important to actually validate that this doesn't happen. But this is sort of the error you would expect to see if that happened. Cool. All right. So that works. And then the other thing we should talk about while we're here is scoping. So scoping gives us a way to actually control this. So in this case, when we're adding these services, when we're adding these things that we can dependency inject, we get a whole bunch of different options there. The default that I've chosen is scoped. So scoped is going to be scoped to the specific invocation against your ASP.NET service. So what that means is that every time that I run this, every time that somebody makes a request against this, we're going to go and create a new one of those services to fulfill that contract, to say, here's this new thing. We're also going to create that controller again. So every time I run this, remember, we're adding onto the counter every single time we do this. So when I run this, we're still getting one, even though every single time we're just adding one more onto the counter. So we can change this. There's other options here that aren't just focusing on this scoped value that you can use. So that's a lot of options. This isn't going to be the best way to find this, is it? Okay, the other option I was thinking of is Singleton. Adding a singleton means it's going to exist once. So the first time that this is requested, it's going to be created, and it's going to be recreated every single time. So let's restart. And then if I actually run this now, we should see 1. But then if I refresh it, now we're going to get 2. Because the state is preserved. That counter that we've created is going to exist as long as this service is running. So depending on what you actually need to do, that may, I guess, influence which one you want to choose for this. But you can kind of define that as part of your platform when you're creating this. But this will just keep incrementing because that's how we've assigned it. We've said it's a singleton, so there will be one of them, and it will be shared across every invocation. The other option was the scoped, which is going to be the same per invocation from a user. So when somebody makes a request to the service, it's going to be created and exist for the entire life of that request and then go away. And then there's one other that I don't remember. I think it's called transient. We'll get there. Because I think we're kind of getting to the end here, and then we can kind of jump into testing and show a little bit more about why this is actually useful for testing. And hopefully we'll have enough time for that. But we'll see. So that's just more about the dependency injection pattern. More about configuring services. We have scoping. Let's see. This is just adding a logger for us to use. And then this one is actually kind of important. Multiple discovery, so multiple different constructor discovery. We can also break this by going into our counter service, our counter controller, and changing this constructor. So instead of doing one with 2 arguments like I have here, one way you could break this is by having a second constructor. This would be a better way to do this. That overloads the constructor. So in this case, we can do something like this. So we have our logger being created there. And then in this case, we're just going to create the counter service. And so what this is doing is having a overloaded constructor. This is valid C# code, but it's not valid for dependency injection. So typically you would actually want to add multiple. I think we got a warning here. Okay, so the warnings we're getting here are because we're not actually initializing all of our injected values. It is not an error because of the type of constructor layout we have. But this actually gives us this, and I think, I've never tried this, but this should cause another exception. So multiple constructors accepting all given argument types have been found. And so the problem here is there's no way for it to tell which constructor it should be invoking because both of those types of services exist. We're saying there is something that can inject the logger and there is something that can inject a counter. Which one should I choose? And it doesn't know. So you're going to get an exception. So ideally what you do is you chain these things if you're trying to inject them. So back to where we were. There we go. And so that is, I guess, another one of the gotchas that you can get into. And there we go. What else? I think that's mostly it. We get through all of this. There's the exception and a good, I guess, call out that you should not do this. And so, yeah, if you're doing injection, having one constructor that actually accepts every parameter and figures it out from there is ideal. And then you can work on it from there. What else? Framework provided services. So this is a series of things that are provided to you automatically by the .NET framework, or not .NET framework, by how you're running your code. So you will get things like a logger, for example, in order to actually handle logging your messages in your controller. Each of these are things that are just provided for you. We have the 3 scopes here. We have transient, scoped, and singleton. They're defined here. Perfect. Because I don't remember what transient does. Lifetime services are created each time they're requested from the service container. So I guess this is sort of an incrementing type of thing. So you have transient, which is going to be created every single time it's requested. So every single time you try to get this new thing, it's going to go and recreate it. You also have scoped, which is going to exist over the entire duration of a single request. So when somebody connects and says, get to the count, that's going to actually exist over the entire duration of that. That might not seem like a big difference from transient. And in such a small example, it really isn't a difference. Where you might see that is actually a broader scoped thing, where you have something that is more complicated than this example. Some call out about entity framework that I'm less familiar with. Accession methods, registers, scoped lifetime by default. Okay, so it sounds like entity framework uses scoped by default. If you're using entity framework, I guess that's a useful thing to know. I don't use it that often, so not that big of something that I'm familiar with. And then the other one is singleton, which actually means that it will exist for the lifetime of the service. So whatever you're actually running, the program that you're running, it's going to exist for the entire time. It'll get created the first time you request it, or if you manually create it, then it'll be fine. So what that could mean is that if you create a singleton and assign it to a controller, if the function attached to that controller is never invoked, your singleton class is never going to get created. Similar to like a static constructor in that way. It's just never going to get created. It's just going to wait until it's needed and then create one and then save it and always reuse that same one. So I guess the two that I've seen the most are singletons and scoped, but you can always figure out which is best for your use case. And then let's see, service registrations. Okay. What else? Oh. Okay. So you can actually provide an implementation like this. But we should play with this a little bit. So we can add a singleton. Let me just quickly double check just to make sure I'm understanding this. So we can add something with a lifetime of the service and the implementation. So that's what we've done. That's the pattern we've used. What are these other ones though? We can add something with a lifetime and just give it the service and then provide an implementation inside of a action or function. The other one looks like we can just provide the implementation. So how does that work? So if I go into here, we can go and look at our program and let's just remove that interface and just say this isn't a thing. We can run this. I think this should still work. We're now creating the same thing and it implements that interface, so it should satisfy our requirement, but it doesn't. Unable to resolve our I counter. Okay. Well, I'm lost. That's okay. So it doesn't quite do what I thought. Okay. I'd have to play with that a little bit more, and I don't think we're gonna go on that journey there. But the other one that looks interesting is this one, where you can actually have something that is actually going to create the thing. So let's do that. It looks like there's a few different options here. So let's try a few of them. So we have our add singleton. Let's do I counter. And in this, we're just going to create a new counter surface. So if you want to initialize your thing inside of how you're actually constructing this, maybe you want some special argument in there or something. And for whatever reason you don't want to grab that at runtime, this might be an option. I'm not entirely sure what I would use this for, because typically I would want to inject values through like environment variables or a config file or something. And that's other stuff that you can inject in, whereas this seems to kind of get around that. So I'm not entirely sure there, but there we go. So that should work. And we should actually get our counter running again. And so we can actually start counting. Then the other option is going to be this, where we can actually have a function. And this is the service provider. Like this. So you can actually provide some function. I've never seen this done, so I'm not entirely sure. But this might be an interesting way if you want to, maybe less interesting in our case because we're using a singleton for here. But if you have something that's more scoped, it could be interesting. And I think we should see the same behavior again. And there we go. One call out I should make. The singleton is not like intended. It's not a database. It's not something where you can actually like persist data. If your service stops, that all goes away. So it's not like a reliable data source, but it is something that you can use if you like need something to call back to. So there's a few fun ways to do that, I guess. Interesting. Let's do that. Oh, there we go. And then let's go and take a look at what else is here. So we can add the singleton. There we go. And then creating a host builder. I don't know what this is either. Huh. Okay. I'm not entirely sure what this is. It looks like it's I'm not sure. The one thing I did want to test that I think would be really interesting is, and I've never tried this before, so we're going to do it live, is what happens if you try to inject something into an injected service? So in this case, we have our counter, right? What if I want to add a logger to it? So I want a counter service with an iLogger of our counter service. Is this something that we can even do? I'm not entirely sure. So let's find out. So logger.log information. It exists. Sure. That's, yeah. And so at least this will give us a way to test if you can actually inject things into injected things. This might not work because I've never tried it before, but it seems like that would be something that you might want to do. So if I go and test this, yeah, so it exists. So this gives you a way, so if as you're registering these services, they also become eligible for dependency injection. Which means you can now inject other things into this. So if you have services that need to call other services and so on, this gives you a way to kind of do that. And so now I'm just getting a logger for free in this. And ASP.NET is actually figuring out how to inject that. So I've used this a whole lot because, for example, you might have a configuration that you need to inject into things so that it knows how it should handle failures or how it should communicate to the database or what it should be doing or what services it needs to be calling. This gives you a way to kind of do that, especially if you're like trying to feature flag things or something. You might want to inject that as a way to kind of flag what's going on. This gives you a way to kind of start injecting those kind of fun features into things. That's really neat. Cool. So what else? All right. And I think that's mostly it. I'm not entirely sure what these try methods are for. Okay, so trying as if you are injecting things that already exist. And I think the reason for that is here. If we try to register, because we're saying we expect one version of this I counter to exist, that's what we're injecting into our service. If there's two of them, that doesn't really make a lot of sense. How do you pick? And we're getting into that same like multiple constructor issue again, where we have two different things and we're trying to figure out how do we actually select which one is the right one. So if we try to create two of these, I think this is going to break and actually cause our service to have an issue. Let's run this. And everything compiles fine. This is unfortunately a trend with dependency injection and things like that. When you are relying on doing these things at runtime, you don't get the advantage of a syntax error. It's not, your build is not going to fail. What's going to fail are going to be your tests and production if you don't have tests. And so ideally, you would have tests in place to prevent you from doing this. Oh, it does work. Well, okay. This might be because I have two of the same thing. So let's copy this. There we go. This again. And let's just re-implement this as another version of a counter service. And I think this might cause this to become an issue because we had previously re-registered something that was the same type. What I'm trying to do is actually cause this to break by running multiple of these and registering two of them against the same interface. But maybe it just works. Huh. Okay. I was expecting that to fail, so I'm not entirely certain. That might be part of why this gets a little bit, why there's more here. So the last one registered wins. We have a way to find this out, actually. We can test. So what happens if you do assign two of these? This is a good thing to know, actually, because this can cause weird things. One of the issues that I run into with dependency injection, especially on a larger service, is it's magic. Things are just appearing and being assigned to different things. So it's hard to tell how things are getting assigned and where that's coming from. It kind of gets simplified by everything being defined here. If you're doing that, having some specific place where you define how these are actually assigned is good. It doesn't have to be in line in your program file. It can be in some other class, but keeping it relatively contained can be useful. If things are just injecting themselves into your scope all over the place, it can get really hard really quickly to actually figure out how things got there and why your class is behaving, especially if you can overlap specific things. So let's go and do, this is our counter service reporting in. Counter service reporting in again. Cool. All right. So we're going to have some really fun log messages. And we should only get one of those because it's going to pick one that's going to get assigned to our controller that we're going to create. So when I go and refresh this, our controller gets called and one of these gets invoked, and it looks like it's the second one. So whichever one you initialize second is actually going to be the one that's used, which means that if you're expecting your initial counter to be used, that can be a problem. It can also create all sorts of weird behaviors if you've scattered these definitions all over the place. This isn't going to be valid code, but let's just put it inside of here for some reason. So if it managed to live in here, I'm not working in this file. I don't care about the weather controller. But if for whatever reason the weather controller is suddenly injecting this thing later, now suddenly the behavior of what I'm actually expecting is going to change. This is one of the downsides of dependency injection and inversion of control, is that you do not have direct control over what you're doing. Again, I like to use cars as an example for this because they're actually a pretty handy way to talk about this. If you're thinking about like buying a car, you can change the wheels on that. You can go and change the upholstery inside of it. You can change the windshield. All of that is a different service or a different thing that you can actually go and swap out. It might have defaults. It might have something that you want to actually start with. You can actually go back and just say, actually, no, we don't want that. For our off-road winter environment, we want snow tires. That's something different. We're going to need to inject this into our car and make our car actually use these winter tires so that it can actually handle snow. That might not be necessary in all cars, though, so you don't want to just like declare all cars have snow tires because maybe that isn't great. Anyway, this is kind of why this is fun. It's also why it causes lots of weird issues if you're not careful with it. It can be really difficult to track down these errors on bigger projects if things are defined in lots of different places. And so, especially if you don't have access to like running a debugger in production, which isn't very common, then how do you actually go and figure that out? It's hard. So the best way is kind of writing really good tests that actually validate that these things exist, that your actual end-to-end integration works, but also taking advantage of this and using it as a way to actually validate these services. Like we have written this counter service here. That's not the right thing. This counter controller that's actually trying to increment a counter and do something. So what this is actually doing is it's a persistent count of how many times somebody has run this function since we started it. If we want to actually validate that, it can be difficult, especially if that is actually an invocation to like a database. We're trying to keep count in a database. That can be really hard. When really what we want to do is validate, does the number go up? We're just trying to mock out the entire database, because if you actually include that database in your test, suddenly it gets complicated. Now your entire test depends on the schema of that database and all of the connections along that route to the database. So you suddenly take a really small like unit size test and turn it into an end-to-end or integration test. And that increases the time and duration. It increases the cost of actually running that test. It also increases the flakiness of that test. How often that test is just going to fail, even though it isn't actually, your code isn't broken. That's what a flaky test is your test is no longer passing, but the code is valid. The code does what it's supposed to. Just something in the configuration along the way caused that to no longer work. Maybe something timed out along the way. Maybe your database connection is taking too long. Maybe it's on the other side of the world, and for whatever reason, that just takes a long time. However that's happening, you typically want to avoid that by swapping that out for something that's super small, like this counter service. Now, this is a really fast operation. You can do this really quick. And so you don't need to worry about all of that. And it's not going to introduce all of these extra dependencies into what you're trying to do. Sorry, I don't have enough time to actually like go through and show testing. So we're going to talk a little bit. If anybody has questions about dependency injection and inversion of control, I would be happy to answer. This is something that I find really fascinating. And I've just been learning a little bit more about this. Most of what I've done has been in Java Spring. So if that's interesting and people have questions there too, I might be able to help. But yeah, I think that's mostly it. We haven't tried. Got a bunch of extra stuff, but we haven't tried doing the transient definition yet. So we can try that and see what happens. And I'm kind of curious. I also really like that you can inject things into once they get added as a service, or once you actually add something here, that you can actually inject other things into it is really handy. Another thing that would actually be kind of interesting if anybody watching is interested is figuring out how to take advantage of this capability outside of ASP.NET, outside of this framework that's already handling it. Maybe you want dependency injection in your console app. Can you do that? I think so, but I've never tried it. So if somebody wants to find like a video like this where we kind of dive into that, let me know, and then we can take a shot at it. So this transient definition should work just like our scoped version, where it's going to sit like this. How can we? Well, actually, we could change this. Let's go. We have a few minutes, so let's actually add a counter. So let's do a I extra. Do an I adder because sure. So I adder does this. Why are we getting? Okay, that might already exist inside of a different thing. So let's I counter adding adder. Does that work? Where am I going wrong? Why is this? I think this isn't an issue, and I just need to do this. I think it should fix itself. Yeah. Okay. So we're just going to ignore those red squiggly lines. That's a different problem. And let's do int count. Let's just keep all of it because sure. Actually, yeah. Let's do our counter is going to be count, and our adder is going to be our add. And so we can create a counter service that implements the counter. And we're just going to get rid of the adding. And then our counter service, again, we're just going to say our adder service. Okay, it got renamed, so it got weird, but that's okay. So we can just get rid of the count here and have this implement I adder. So now we have something that's actually adding and something that is counting, two completely separate things, and we're just going to inject them into one another. So that this way you can actually kind of separate these things out. This is probably taking this a little bit far, but the cool thing here is that now you can actually remove, in this case, we're taking the state management and the action of actually acting on this state and separating those out. So kind of taking and implementing more of like an actor type pattern, where we have something that does an action and something that does a state. And then in this case, this just needs a private I counter, and we'll just store our counter in here. And then this can just be injected in like this. And then counter equals our counter. And then instead of this.count, we're just going to do our counter.count and increment the counter like this. But we don't have it as something that can be assigned to. So we actually have to change that. That's interesting. I should have seen that coming, but that's okay. So we're gonna add a setter here. So this gives us something that can actually be added and subtracted from. And we also have the state. So let's go and use this now. So we have our there we go. We need to implement the setter because it's now public. And we can work with the counter. So now this no longer works, but I can inject that here. So I adder, here's our adder service. And then we'll do adder service. There we go. Implement that and reference it here. And then here, we want to have our adder service add its amount to whatever that is. And then actually, yeah, no, this will work. And then we can get the count from the counter service. So depending on how we actually reference these, this should do very different things, which should be fun. So let's go and try this. Okay. I'm not entirely sure why this thinks there's two definitions of this function, but that I think we can just ignore. And we'll just call this the adder service. There we go. And then fix our file error and run this. This isn't going to work because I haven't injected these yet. So if I go and run this, well, we're going to run into issues because this doesn't exist anymore. The adder part of this is undefined. So it'll probably build. There we go. And I can probably get as far as this before everything explodes and we get an error that we need an I adder. So that part's broken. So let's go and inject this. Go and add transient, our I adder. This is going to be every single time it's referenced. We're going to get a brand new one. And this needs to do adder service. There we go. And so I can, that's not going to work. Restart this. There we go. And so these are transient references. So every time we run this, we should get 0 because we are injecting a new transient version of our counter into every reference that's doing this, which means that the counter that gets injected into this adder service and the counter that gets injected into the count controller are two separate versions. They're two separate references. So they don't actually align. We just completely miss. And so what that means is that I'm adding something to a completely separate counter. But if I go into here and change this to be a scope reference, so let's just make both of these scope. What I should see is that now we're going to get 1. So instead of 0, because we're setting the value to something else, the reference should exist over the entire scope of the call. So now, when I actually go here and refresh this, we get 1 because the counter is the same in our controller and in our adder. And then if I go and expand this out one more time to our singleton, now we should see this persist even for the entire thing, just like it was previously. So this is probably a better example of how those scoping or how the, I guess, scoping of the services that you're adding matters. Because as we're changing this, we're getting different behaviors in our program. So depending on what you need, you'll want to choose a different one. And now we can actually increment and count up from this. So yeah, there you go. I think that's enough for dependency injection. This is probably a lot, but hopefully this is helpful. I use this mostly to help enable testing of more complicated things. If you are interested in like sort of the format that we're doing here and want to see more, we do have a survey that we would love for you to fill out. It tells me if I'm doing a good job and if you want to see more of this, or if you want us to do something else. So feel free to do that. No, we are not going to play Minecraft. At least I'm not. I'm not familiar with the schedule, so maybe somebody is afterwards. But I am not. So yeah, thanks so much for watching. And yeah, I will see you, I guess, next week. Oh, not next week. Never mind.
Thank you, Sam. And thank you, everyone. Until next time. Bye.
Bye, everyone.